Mr. Chairman, ladies and gentlemen, this presentation is about biorefinery measurements. Now we are talking about any way to achieve information about biorefineries that are strongly related to bioeconomy, because these refineries are the producers of the bioproducts from the bio-based materials. In the biorefineries, the raw material is a biomass, any bio-based material. It is converted by processing it with multiple sub-processes to some bioproducts. And these processes can be mechanical, thermal, chemical, biological. The end product or the side products are bioproducts. This process all together is very complex, and when the society is heading to bioeconomy, these processes also have to work efficiently and with high quality. And this is the reason why the measurements or the information is needed. It is needed for measuring the efficiencies. It is needed to measure the quality. It is needed to achieve any information about, for example, environmental impacts of these refineries. For example, the bio-based raw materials, we need to know the properties, moisture, for example, as it was heard previously, moisture content one, or any other properties that may affect the processing of these materials. On the other hand, the processes itself need to be monitored in order to achieve the most efficient way to process these materials. For example, the energy efficiency and the material efficiency are the most important targets here. Traditionally, measurements or the information from the process is applied or utilized in the process control or the optimization of these processes. But in future, more and more information is needed for public and the authorities. Environmental laws are quite strict. Today, measurements are in these industrial processes, but in many cases, the information is not enough that is getting for now. And this is why I put there yes, no. There are process sensors, analyzers, but the information is not really fully achieved yet. Typically, there are large delays between the measurements and the information. This makes a challenge for the process control and optimization when we are heading to the most efficient way to handle these. The measurements can be very expensive. So they can be expensive with the delay. It's a tricky challenge for these process operators, that if you have a complex measurement that gives delayed information, it's very hard to utilize this information for the control. uncertainties are always related to measurements, but it's a question about how much uncertainty you can tolerate with this measurement. And it also affects to control and optimization of these processes. One example about the new ways to get information about the raw materials of the bioeconomy is presented here. Traditionally, moisture measurement has been a very challenging task. It is still a challenging task. But in this approach, sensor fusion is applied. And this idea is based that the granular material has some mechanic properties that can be seen from the figure. For example, here the falling sawdust forms a pile, and the profile of this pile tells about the properties of this sawdust, including the moisture. This picture here is taken with the mobile phone. It's some 80 euros or something like that. In addition, there is a laser beam marking the profile of the pile. So that was some 20 euros. After that, some heavy calculations with the software-based approach, data analysis, and the result is an estimate absolute values of the moisture content in real time. So this is the whole idea of the research area that we are dealing with. It's about getting information real time from the process with quantified uncertainty. These studies are related to this new biorefinery measurement professorship. It's established a year ago, something like that, and located also in Kajaani Measurement Police, and also financed by these great institutes, including University of Oulu, City of Kajaani, Regional Council of Kainuu, ST1, and Valmet Automation. Shortly, the future that I see, we still need to transform this information to knowledge. It's the next step. So basically, we need more information that leads to more knowledge about these processes. When we do it in real time, it is likely to give us more tools to more efficiently drive these processes. It may include also development of new measurements. But what I see is that the maintenance and the calibration automatically is one of the key issues in these future measurement developments. There are many analyzers and measurements in the industry that are working properly for some time. After that, the measurement is fooling, or the process is fooling the measurement, or some other reasons that the uncertainty of this measurement is increasing. And there we need automatically correct these measurements. So the maintenance of the measurements, the sensors, the analysis is one of the interesting issues here. At the same time, with software-based measurements and sensors, digital twins, predictive mathematical modeling, we are heading to predictive information. So from the real time to predictive one. And this gives even more possibilities to optimally control the bioprocesses. Biorefinery measurements are to provide information for bioeconomy. Thank you.